All right, thanks, Nicole. Good morning, all. My name is Vela. I'm the technical engineer from SuperMap International. Today, it is such a great honor for me to be able to present the topic in SuperMap webinar Philippines with the theme of innovating IT value with geointelligence. So thank you for the chance. I will present the topic of SuperMap solution for smart city, and these presentations will be divided into four main outlines. Now let's jump to the first outline. Okay, the first outline is thoughts on GIS in the development of smart city. This outline is mainly discussed about how a GIS could help in the implementation of smart city projects and describe its use in the constructions of large-scale models of the smart city. All right, the smart city concept is developing very quickly around the world. And this concept is based on the use of geospatial data. The successful implementations of a smart city projects requires the development of a digital system that can manage and visualize the geospatial data in a user-friendly environment. The Geographic Information System, or GIS, offers advanced and user-friendly capabilities for smart city projects. That's why GIS is everywhere at smart city. There are lots of platforms used for the development of smart city. GIS platform is one of them. So GIS platform could help to enhance the understanding on the city conditions through location information. What GIS can do in representing city condition as smart city applications. So GIS can perform some of the applications such as visual display, location services, heat map, simulation, exercise applications, spatial analysis, and planning models in 2D and 3D space. Those functionality could be the features of smart city applications. For example, at business applications, traffic applications, and urban management applications, emergency applications, water applications, and social governance. So I just listed some of the features that can implementing GIS in the system itself. Each GIS actually represents a form of information as an answer to a specific question in certain field. Meanwhile, analyzing the conditions of an area also requires different GIS maps to get more accurate information. Then what to do? If the desired information is complex, then we must merge various types of maps and analyze them together. That's how smart concepts adopt GIS technologies. Okay, this slide shows the strengthened openness of the information provided in smart city applications can be further enhanced with the implementation of GIS technologies. Why do we say like that? The latest GIS trend has been improved significantly. For example, in the field of visualizations and experience enhancement, GIS can display the data in an interactive way through its maps visualization effect, static, chart, report, and else. Besides, the concept of smart city will be more interesting if the system itself could integrate a lot of data and technologies in IT trend. Now, GIS has been achieved those conditions. Also, the combination of GIS and building information modeling, or BIM, provides a powerful tools to construct for the constructions of the urban digital models with georeference data and the visualizations of this data in a user-friendly environment. Now let's take a look on these architectures to know about the future smart city. The implementation of smart city projects is based on number of steps, including construction of the urban digital models, also data collections, data analysis, interactive data visualizations, and so on. On the data collections part, there are many data which can be accessed and also imported into the system, such as IoT streaming data access, industrial database access, BIM structure data aggregations, and video data aggregations. Integration of many data will make the system contains rich data display. And the data could also be enhanced by images, video, audio file, resulting in the constructions of urban big data. And another step in implementing a smart city projects concerns the development of the analytic environment, which converts real-time data and also the historical data into the operational data that improve the security, efficiency, and quality of urban system. And the last steps, which is also important step, is developing an interactive display that allows user to interact with the smart cities component and the stakeholder in a user-friendly environment. Okay, so this is a figure of smart city neural network. Since smart city projects are based on the collections, analysis, sharing, and visualizations of data concerning system and services, GIS allows smart city managers to utilize a user-friendly and widely used digital system in the management of urban system. We all know that there are many aspects contribute in smart city. Also many categories involved, such as we have smart homes, smart wear, smart parking, smart transportations, and etc. And also GIS could combine those kind of technologies to provide powerful capacities for a successful implementation of smart city projects. So after elaborating the thoughts on GIS in the development of smart city, now let's discuss the basic concept of smart cities. So what are smart cities? First, we have to know that the definition of smart city itself. Okay, practically, smart cities are urban areas that use different types of technologies to collect data and use this data to manage assets and resource efficiently. Generally speaking, smart city perform a smart utilization of ICT to enhance the city's livability, workability, and sustainability. And as mentioned earlier on the earlier slide, smart city must perform three important tasks. Those are collections, and then sharing, and analysis. Besides understanding on what's happening on the city, other objective of the smart city is also predict what's likely to happen based on the real-time and historical data stored on the system. Now the question is, who should be involved in adopting smart city concept? So all stakeholders surrounding in the smart city. Oh, slide refresh seems to be delayed. Okay. All stakeholders surrounding the smart city, either direct and also either direct stakeholders or indirect stakeholders, must take part in the development of smart city. On the other hand, citizens must be included in a smart city. Citizens are a key element of smart cities as they form such a city through continuous interactions. I just mentioned some of the stakeholders involved. Those are like energy planners and provider, city managers, city planners, building architect, professional, economists, transport planner, utility managers or engineers, and also system or software engineers. Okay. But implementing smart city concept, some countries requires to overcome the challenges at the very beginning. Now let's see what are the challenges. Let me check. Okay. Now, let's see what are challenges. We know that in the city management, there are a lot of complex static and dynamic operation which needs to be considered while building the smart city applications. Not to mention collecting the data which is being needed for further development of smart city also sometimes become a bottleneck because it's really hard to find a proper, reliable data with the right information. Adopting latest trend of GIS technologies also can cause a problem because at some places, they only have lack of trained staff to perform these advanced technologies. Therefore, another challenge shows up. The system developer needs to develop an easy-to-use front-end tools for day-to-day operations, planning, and decision, so that it can be educated to all stakeholders in each level of administrations. All right, so those challenges I just mentioned in the earlier slides needs to be solved first because in smart city concept or GIS or geospatial technologies incorporates or integrates with emerging and innovative technologies which require a complex system. So those technologies are as follows, like virtual reality, or augmented reality, then predictive analytics, BIM, and also CIM, building information modeling, and the 3D modeling and visualizations. And we have many more, like video analytics from CCTV, and also simulations, smart sensors and IoT devices, and also autonomous vehicle or vessel or aircraft. So we have many questions in different fields that involve many stakeholders, which can be answered by adopting the smart city technologies, such as how cities are supplied, how cities are regulated, how cities get basic needs managed, and how citizen mobility gets supported, how work and living places are provided. I just listed on the slides about the questions. And, those questions could be answered correctly if we have a system that can analyze the data conditions of the city itself for further decisions making by the city manager. Okay, so now let's elaborate more on how SuperMap faces these challenges. So we're going to enter the SuperMap solution for smart city applications. The first one, let's talk about the features. So I'm not going to talk about the basic operation of GIS, which is in the two-dimensional operation, because I believe that all of the audience here are already familiar with those technologies. What I'm going to talk is the enhancement of GIS technologies in smart city application. So let's see the first one. This is the first one. I'm really sorry if the video seems not so clear because I think it's the platform problem. I mean the Zoom. So the first one is the 3D city visualizations. Displaying the city in 3D ways will make the audience or users easily to understand about the real conditions of the city. We can use many of 3D data format to display it as 3D scene. But in this video, we use the oblique photogrammetry data of UAV to visualize the 3D city. Next features is the thematic map. So besides performing thematic map on two-dimensional data, why don't we also perform the thematic map on 3D model data? It will be more realistic because 3D data represents as a models of the real world. And this is an example for thematic map referring to attributes of building. Okay, next slide is the 3D spatial query. Okay, in the 3D model data, we also can perform a spatial query and display the result on the model itself. The spatial query command is used to compose filter expressions according to the spatial relationship among geometric objects and get objects satisfying the filter condition from the existing data. Actually, it can be achieved in two-dimension data too, but this one, I'm highlighting about the 3D spatial query. Okay, next one. Let me check about the connection first, because it seems the slide has some delay. Okay, no. Let's continue. So next feature is communication signal strength simulations. Actually, there is a new technologies which called as a voxel grid in GIS. Voxel grid can represent the condition of information, which cannot be seen, such as communication signal strength, pollutions, and etc. by interpolating 3D sample data. And as a result, it will create a 3D interpolations which represent the information we need based on the data that has been interpolated. This is really interesting for smart city application analysis. Next features is displaying the pollution field simulations in a timely manner. So it can be displayed by different color at different intensity of the pollutions itself. And also we can display it in the 3D scene. Features, we all know that many smart city applications would likely to access and display CCTV camera for return. So we can locate the CCTV camera distributions. While people click the point, it will directly display the video in the real-time situation. Yes. And the next features is the integrations with IoT camera. This feature is the unique one because not only by displaying the distribution of CCTV camera as a point, we could also integrate the camera with our 3D models at the specified locations and can be integrated seamlessly. Next features is another example of integration. So we could also integrate street view data with 3D oblique photogrammetry seamlessly. I'm showing you the video. Okay, next one. And the last feature I want to show you is the map dashboard. So we can create a map dashboard which can display our map view, statistic, chart, and other information as static data and also real-time data. It presents the data result efficiently, and with the provided system monitoring dashboard, you can intuitively understand the overall situations of the portal and the use situation of resources. There are a lot of interesting features in GIS that can enhance the development of smart city applications. But since the time is very limited, we just try to summary all of the technologies. So next, I want you to introduce the platform that SuperMap provides to support the development of smart city applications. Let's open it. So this is, I think Jason is already mentioned this product family. Okay, we have many products in multi-terminal platform. We have PC GIS, Web GIS, and Mobile GIS. Also the Cloud GIS. For PC GIS, usually we use SuperMap iDesktop.net because it can perform in Windows operating system. And for the web development platform, we will use SuperMap in JavaScript or SuperMap iGuide Python. And if we want to display or render 3D, so we use SuperMap iClient 3D for WebGL. And we have the ready-to-use application in mobile GIS, which is the SuperMap iTablet. And we also have the development platform for mobile, which is the SuperMap iMobile. And for Cloud GIS server, we have Super Server. This is actually a application server. SuperMap is a GIS portal platform for integrating, sharing, and managing GIS resources. This is zero code visualization customizations. So we don't need to code anything to make a good portal GIS. And we also have SuperMap IH, which is an GIS server. And we have SuperMap iManager, which is a GIS cloud management system. And this is all of our product family that can support the smart city projects in your area. And we could also integrate Internet of Things in data with our platform, as mentioned on this video. Can we access and store our platform for instant applications displayed by iDesktop, iMobile, and also iPortal. So for data analysis, SuperMap mainly introduces hundreds of types of spatial analysis. SuperMap is constantly optimizing the performance of spatial analysis operators and gradually integrating multiple technologies, integrations of distributed technologies and also Spark. And at present, more than 60 analysis operators with distributed processing capabilities have been formed by SuperMap. So after the introductions of our platform, show you some cases of smart city application which has been created by SuperMap platform. So let's see the first cases, which is the platform of location timing insight into big data. These applications targeted for government, city planning, and enterprise, which needs insights, location selections. And this application can perform a real-time crowd monitoring, travel route selections, and source analysis. It's more likely implemented for smart transportations. So you can see on this figure, it displays statistic data stats, reports, statistic points, AI, and also others. Okay, these applications could also achieve traffic data functions and open sharing ability by merging locations and transportation data collected by some provider. It combines vehicle reversion data from taxi provider, flight data, vehicle data, GPS data, trajectory data, and so on. And not only internet enterprise collections, but other data should also be integrated into the system. Those data will be extracted, analyzed for further use. Okay, next. So this is the overview of the applications. The urban travel overview is based on the terminal trajectory, mobile network, behavior preference, car hailing trajectory data from China Unicom and this taxi provider in China. And it aims to describe the traffic status of the city and every area under observations. and supports the travel time, also the travel distance, travel trajectory, and etc. And it shows a multidimensional analysis of a travel behavior and display the form of thermal migration map and population heat map to show the traffic migration situations of people and vehicle with special holidays, major event traffic protection, weather, and so on. And through the massive track data of people and vehicles, the whole city can be scanned in time, so a graph of the overall operations in the city. Okay, next one. Okay, these applications actually provide some of the features as the following. The first one is the real-time traffic conditions, trajectory, and also alarmation to quickly detect abnormal conditions point. And we have historical alarms, heat fluctuations, and also timely attention to changes in the city situations. And this real-time delay ranking, parking number, ranking dynamic refresh, and real-time control of intersection changes also provided in these applications. So this is the last slide I want to show you for the first cases. Next, we will move to the second cases.
Okay, so I'm really sorry for the inconvenience. Okay, so let's continue to the second cases. The second cases are come from Petaling Jaya. This is in Malaysia. A use case of geospatial centric development of smart city. This project is initiated in 2016 and target 2030 for completion. This aims to embrace GIS as the unifying technologies for planning and development of smart PG. And it has selected SuperMap GIS as the GIS platform of choices. And this project actually developed applications in web applications and also in mobile applications to engage citizens. It deploys IoT sensors and intelligent CCTVs on system. So now let's see some figure on these applications. Okay, this is the first figures on these applications. This is a flood control disaster management system. Actually, in Smart PG, there are a lot of applications based on different industry. This is for disaster management. They have flood control and disaster management system. You can see that many data are displaying as maps, statistics, and also charts. The next figure, this is from different industry, but in the same application, which is the Smart PG, they also have an intelligent transport system to show the distribution of like city bus, informations alert, and also the commuter rates and commuter passenger statistic and other aspects. So we can get many kind of dashboard in one application. So it's not limited to only one dashboard in one application. Next one is for natural environment. They have low carbon dashboard, and user can analyze based on the data display on this dashboard in an effective way. Okay, next one. Not only in 2 dimensions, they also have smart zoning assessment. Wait, check. Is there any? Okay, not only in 2D, they also have a smart zoning assessment in 3D using some 3D spatial analysis, such as spatial query and buffer zones. And the next cases I want to show you is the smart park. So smart park achieves some solutions Those are park visualizations, park navigation, park facilities management, park security management, management of vehicles, personnel in the park, and also park efficiency management. And this one is the solution of Smart Park, tourist attractions navigation applications. The application scenarios are map positioning and walking navigations in scenic spots. Main business of these applications, from the figure left to right, the pictures are introduced as follows. The first one in the left side, ranking of scenic spot, and the second one is browse route recommendations. The third one on the middle is detailed introductions of attractions. And the fourth one is walking navigation in the scenic area. And the last one is retrieval of peripheral service facilities. And this is another solution, which is three-dimensional tourism scenic area management system. And this area is a scenic area dominated by typical karst natural scenery with a total area of 15 square kilometers. Next cases is come from India, which is the Jabalpur Smart City. These applications aims to monitor traffic signals because for case of medical emergency, it becomes case of life and also that. And it display fast and accurate capture of location of emergency on GIS maps and accurate real-time location information of emergency vehicle. This is an appropriate solutions to handle both emergency vehicle and also the traffic signals. Next case is Smart Street Operation Center. So Smart Street Operation Center, this is located in Beijing. They have the first one is 2D and 3D visualizations and also the night scene mode. And we have the case management, CCTV integrations, patrol management, and also early warning information. And we have also special effects. It's used in smart cities and the effect is really good. And this is the last slide. The last case I want to show you, which is the smart security. Actually, this is full of video. I will show you a video of our smart city solution, which is specific to smart security. This video will be also my last slide on these presentations. I hope the connection is good enough to play this video. Let's see.
Smart City is an innovative city that utilizes technology trend with the information and communication of technology approach to improve the quality of life, operational efficiency in economic, social, and environmental aspects for the benefit of present and future generations. One of the pillars of a sustainable city in the future is a safe and comfortable city, which we call smart security. It aims to improve government capabilities to protect public lives and property, to safeguard national security and social stability, as well as to promote economic and social comprehensive, coordinated and sustainable development. It integrates modern technologies such as wireless trunking system, closed-circuit television system, global navigation satellite system, geographic information system, Internet of Things, artificial intelligence, big data, cloud computing, and computer telephony integration, etc. How GIS helps police officers to fight crime is one of the objectives of smart security. The police has all sorts of data. There is data on criminal incidents, arrest calls for service information, etc. All that is data. Without GIS, we really can't analyze where things happen in relation to other things. GIS helps us put incidents on a map and then look at the relationship between where this crime occurred, where this person was contacted by the police department. So it really brings us everything together. While every officer has access to GIS data in the form of maps, if they're going out to a particular location, they can actually look on a map and see what accidents have happened around that location before they even get there. Officer could also create heat maps of crime which will figure out of what crimes that occurring the most in one area. Help analyze and figure out who can be deployed to combat that crime. With the help of social media, officer can also map the crowd and they can take a look on how large the crowds were and define how to prevent crime happen in that crowd. The smart security mainly has 3 levels. Number 1. Management of basic police data related to public security business, including population, community, key objects, facilities, roads, bridges, routes, events, cases, etc. Number 2. Police dispatch and command, including graphical command plan, GPS real-time scheduling, capture, checkpoint, evacuation, path analysis, etc. Number 3. Assistant decision-making and analysis, including population analysis, crime mapping, crime analysis, accommodation track, crime track, and traffic accident analysis. SuperMap Smart Security System will help you enhance government's capabilities of unified command, timely response, and cross-department coordination. It also helps improve the efficiency of emergency receiving, handling, supervising, and closing, as well as keeping secure records of all operations.
So I guess that's all for now. Thank you for your attentions. Again, I'm really sorry for the connections. So I hope to see you again next time. And if you have any questions, please submit on the Q&A box or on the chat room. Or you can also leave the message to my email, fela@supermap.com. All right, thank you all.